Welcome to this video. Here I am Padma Priya as an assistant professor from Department of Artificial Intelligence and Data Science, KIT Kalaignar Karnanadi Institute of Technology, Coimbatore. In this video, you are going to learn about the concept of spread spectrum under wireless technologies. Yes. Yes, what is spread spectrum? This explains the spread spectrum transmits radio signals over a wide range of frequencies, and also the original signal which is combined with the special spreading code which enlarges the bandwidth. This creates a protective envelope around the signal, making it difficult to intercept or jam, and also the main usage of secure communication systems. And uh, spread spectrum, which is a wireless communication technique in which the transmitted signal is spread over a bandwidth much larger than the minimum required, and the spreading improves resistance to interference, jamming, and unauthorized interception, thereby increasing security and reliability. Here, the principles of spread spectrum, which explains the based on redundancy. How it is based on redundancy? It seems the bandwidth allocated is much larger than necessary. The spreading process happens after signal generation, allowing the system to combat noise and interference with the effectively. And here, which the condition based is required for spread spectrum, how it is related to modulated signal bandwidth is much larger than the baseband signal bandwidth. A pseudo noise code is used to spread the signal, and same the pseudo code must be used at the receiver to despread and recover the original signal. Yes, here some characteristics of spread spectrum have some several advantages like high channel capacity, resistance to multipath propagation, high security and low probability of interception, strong resistance to jamming, support for multiple users. That means multiple access capability. Here the few techniques, which is a frequency hopping spread spectrum, direct sequence spread spectrum. Here, the input data is first encoded and modulated to produce a narrowband signal. A spreading code generated using a pseudo-random generator which spreads the signal over a wide bandwidth. At the receiver, the same code is used to despread and decode the signal. Here, the general model for the spread spectrum system. This diagram explains which includes channel encoder, modulator, spreading code generator, channel, despreading and decoding at the receiver, and also illustrates how spreading and despreading occurs. Yes, next, the spread spectrum provides gains such as immunity to noise, multipath distortion, and jamming, signal hiding and encryption. Only authorized receivers with the correct code can decode, supports multiple users using CDM and CDMA. And this pseudo-random numbers are generated using algorithms and on an initial seed. They are deterministic but appear random. Knowledge of the algorithm and seed is required to predict the sequence, which adds security to spread spectrum systems. This frequency hopping spread spectrum, the signal hops between different frequencies according to a pseudo-random sequence. The transmitter and receiver remain synchronized. Eavesdroppers hear only random noise, and jamming affects only small portions of data. The available bandwidth is divided into multiple channels. Each channel is used for a short duration. For example, 300 meters in IEEE 802.11. The hopping sequence is controlled by the spreading code. And this is the frequency hopping example. This one explains visually how the carrier frequency changes with time following a hopping pattern defined by the spreading code. And this is the frequency hopping transmitter system. This transmitter generates data, applies modulation, and hops the carrier frequency according to the pseudocode sequence before transmission. This is the receiver system. The receiver follows the same hopping sequence as the transmitter to correctly receive and demodulate the signal. And this is this low frequency hopping spectrum, which is frequency hop duration is longer than signal symbol duration. Fast frequency hopping spectrum, which frequency hop duration is shorter than signal symbol duration. And the fast frequency hopping spectrum provides better resistance to noise and jamming. And this is the slow frequency hopping spectrum by using MFSK. This is the M array frequency shift keying, where the carrier frequency remains constant for multiple symbols. And this is the fastest one, which multiple frequency hops occur during a single symbol transmission, improving performance in interference prone environments. And this is based on the performance considerations, uses a large number of frequencies, which improves resistance to jamming and interference. Direct sequence spectrum, which each data bit is represented by multiple chips using a spreading code. The signal bandwidth increases in proportion to the number of chips, improving security and interference resistance. And these are the examples of direct sequence. How input data bits are combined with the spreading code using XOR operation to generate the spread signal. And this is the this is the transmitter, which multiplies the input data with the spreading code and modulates the result for transmission. This is the receiver, multiple the received signal with the same spreading code to recover the original data. This is the direct sequence spread spectrum, which how binary phase shift keying is used in this spread spectrum for modulation and demodulation. This is the approximate one. This shows that direct sequence spread spectrum signals occupy a much wider bandwidth compared to narrow bandwidth signals. And this is the CDMA code division multiple access, allows multiple users to share the same bandwidth using unique orthogonal spreading codes. Each user's signal can be spreaded at the receiver. This is the CDMA example. With multiple users shows how different spreading codes allow simultaneous communication without interference. And this shows that encoding and decoding in CDMA, if a user sends bit 1, its code is transmitted for bit 0. The complement code is sent. Orthogonal codes prevent interference. And the CDMA for direct sequence spread spectrum, which multiple users uses the different orthogonal pseudocode sequence, and each user's data is modulated using the spread spectrum. And this explains how CDMA operates within DSS systems and supporting multiple simultaneous users. And this is the illustration of multiple channel CDMA encoding and decoding, showing how signals are combined and separated using the spreading codes. I hope you all have understood about the spread spectrum. Thank you for watching this video.